Let's go. Nej, 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 nej. Nej, nej, nej. Du, du, du. Du, du, du. Stream is live. Stream. Okay, let's post to LinkedIn that we are live. Alice, du får vara där. Där får du vara, Alice. We're live, simulation, modeling. Let's go. Live stream simulation. Oh yeah. Happy face. All right. 3 viewers. Welcome. I haven't really gotten started yet. Is there a chat somewhere? Yes, there is. Reko Gura says, can't hear me. That's your fault if you can't hear me. I think it's working. Can't hear me. I can hear myself. So it should be working. And I have a cat in my lap. It's usually the case. Alice, she likes simulation, I guess. So I haven't made any hard plans what to do today, so I am trying to watch the chat on Twitch and also the chat on LinkedIn. So if you have any suggestions what you would like to see, I'm open for that. I was thinking about one thing. Trams in the city, it's not as contemporary as maybe taxi cars, or if you take Ubers, or whatever the apps are called. So if you imagine a road system and you would like to call for transportation jobs, you could imagine you have taxi cars instead, and they go into parking when they're not being used. And as a client wants to be transported from A to B, there is a service request to the taxi cars, and then maybe the closest taxi gets selected or something. So maybe we should leave trams and go towards taxis. Taxi traffic is not really similar to factories, because factories tend to have things more scheduled. What should happen? It's not that someone just wants to transport all of a sudden and you get it. Could of course be that also. So taxis or trams or something else. I'm still waiting for feedback. I know there's someone watching. You should give me a pointer. What do you want to see? I did download a taxi 3D model, because if we keep looking at this, they don't look like taxis. Let's see if we can fix that then. So in any visualization that you do, I recommend that you put some time and effort into the visual part of it. So trying to make the system look like what it does for your customer. So I'm gonna take this transporter, I'm gonna duplicate that one. Now I get it into user objects. So transporter, I'm gonna call it taxi. And let's see if we can open that taxi in 3D. Here we go. And use another 3D model that I found for free online. Where did it go? It went here. Let's see. And now I have a cat on my mouse. My mouse pad. Alice, hur du? Där får du vara. Okay. Let's see if we can import the 3D. Edit, import graphics. In this folder there is no format that I can use. What format did I get? The taxi that I downloaded is an OBJ, so I can't import OBJ. That's too bad. So let's use another tool, another software called Visual Components. That's really good for reading different file formats. So I'm going to use Visual Components in this case. It's also a simulation software for factory systems. But I'm going to use it to import the geometry here instead. Import the taxi. Let's go. Here we go. Here we have some sort of taxi. It's white. No textures. I do have a material file. Why don't I get the textures? I'm gonna try the import one more time. All supported. Let's say it is OBJ. I can't see it. Yeah, never mind. Can you go with 2? No, you cannot. So import that one. Organize the geometry by material, feature tree full. Include materials, textures. Let's try that one. And if we can't get the color right, no big deal. What color is a taxi? The material should be yellow. If you're thinking what I'm thinking. So we assign, is that one feature? Okay, that was one feature. Let's do some rubber on the tires. You get the trims as well, but I'm fine with that. Doesn't have to be perfect. I'm not going to spend too much time on it. I'm just happy that it's similar to a taxi. Okay. Export that geometry. Only do selected geometry. And I know JT should work. Let's put it on the desktop. Call it taxi. And now import graphics from the desktop. It's not done yet. Do, 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 do. Is it done? No. Still waiting for the export. Okay, as we're waiting for that geometry file, if we want to make this taxi service, we should be thinking about the logic here. So maybe we need a control frame for the taxi service in that case. And yesterday I did not spend much time cleaning this, but I usually do this, that if you have a method, and this method is being called by that one, I put this method under that one with a bit of indentation. Init first cleaning is also called by init, so that's listed below there. These here are a bit messy. These are a list of all the jobs. I don't think I ever began to use that one yesterday, so I'm gonna delete it because we don't need it. The destinations, I don't think I used that one either. I did use cleaning schedule, and there is a method to get to the next destination as you're running the model, and then this is an exit control of the tracks. So to keep this a bit clean, if this is for init, let's keep it there. And these are more for runtime during simulation. Let's just keep them. Oops. Keep them here. So we get like one column for init and one column for during runtime. If we want to, we can of course put these in subfolders or subframes. And I think if we do the taxi service, I'm actually going to start creating that logic inside a subframe. So this is under construction. I'm going to activate the caption for it so we can see it's called frame. Let's call it taxi logic. Or taxi control. And if you go into taxi control, here we can put all the methods and all the logic that we need for that. So I'm going to put in a method and a data table. What are we going to use those for? Let's see. The taxi control, open that in a new window, and the mainframe like so. Taxi control, we should have some way that if you want to take a taxi, you want to call the service and you want to provide them with your destination and where you want to go, like your location and the destination you wish to go to. Maybe you would like to schedule the taxi to come pick you up at right now, or you want to schedule it to come to pick you up in 1 hour. So if we think of those three, so we need some sort of logic to add a new taxi job. So we add a job. The parameters should be the customer location, customer destination. Those can be objects. And when to pick them up. When pickup. That can be a date time for our purposes. Ooh, getting picked up for date, maybe. So, since this is a simulation software and we can apply algorithms when we have the data sorted, you could specify when you want the pickup. You could also ask the customer, yeah, but when do you wish to arrive? So we could also provide when arrive, but we're going to use when pickup for now. So this will be provided by the customer when they're adding a request. So we're gonna put a list of requests. This is gonna be our list of requests. And let's use one column per parameter. Customer location. These are objects, so let's make those two objects. The last time is a date time. Let's put in date time on that one. Customer location and destination. When pickup is a really good name, so I'm going to reuse that one. So when you call the taxi service, they might reply, sorry, we cannot handle your request right now, we are too busy. We're not going to fit that in right now, but I'm just going to assume that it is possible. So I'm going to put in a comment, assume that we can accept the request, and then we append the request to requests table. So we want a new row to put all the data in the table. So the new row is going to be the requests, how many we have right now, plus 1. So we're going to start this table being 0 in y dimension, plus 1. So the first row is going to be 1. And then we just put in on requests, customer location on the new row is going to be what we pass in here, so the customer location. And now I always reuse this row, so Control D. Woo! Control D 2 times, and then just this destination is that one, and when pickup is that one, and that should be that one, and this is that. Okay. Now we have added the job, so we know we have at least one request, or one request. So the next question now becomes for the operator, do we have any available taxis, or do we have taxis to schedule to do this? And since it's a simulation toolbox, we might have an inquiry. Given all the requests that we think we're going to get, how many taxis will we need to accommodate all those requests without any customer ever being picked up late? That is, you want to dimension the system so you can cover 100% of all cases without ever being late. But you're probably gonna end up with very many taxis, and most of the time you will not use them all. So it becomes a give and take. But let's play with this a bit, and maybe it can become apparent what I mean. So I'm going to close this method. So we have a method for adding a job to the taxi control. It should be added to requests. I'm going to put in a small init method in here as well to init this table to be empty, so we do not start with any requests. So the thing we're going to do in the init is simply requests delete, and that's going to be fine. like so. These are all the requests. We can use this to add. Why call it job when this is called requests? Requests. Add request. And now we're gonna have to have a taxi fleet listing all the available cars in that fleet. So let's create another data table, call it taxi fleet. The taxi fleet, I'm gonna try and make this simple enough. It's gonna list all the taxis, so we want to reference those taxi objects. These are gonna be a list of all the taxis. And here I'm gonna put the status of that taxi. So when the simulation starts, I think we're also gonna want to be able to add, oops, I copied these. We're gonna be able to, we want to add a few taxis when we start the model. I'm gonna call it create taxi. Maybe this should be for creating one taxi. Let's try and do without parameters. But this is the class that we want to use, the taxi that I defined. Let's see if we can fix the 3D model now. Import graphics. Desktop. Aha! Woohoo! Yeah. Alright, we got a taxi. It's small and it's riding on top of this one. If we show the graphic structure, we have the taxi that's here, and we have the other old stuff here. Let's see if we can just delete these other things. And this is the taxi. And let's open up the 3D properties for the taxi. Move it to 0. It's on 0 and the scale is a bit small for a taxi. Should it be scale times 10? Maybe. Let's go with a scale of 10. Now this is the taxi class that I wish to use. So the taxi class, so we instantiate, we create a taxi, so a new taxi is going to be that taxi class dot create, and we need to create it in a location. I call this garage. We're gonna try and do this in a way that it's gonna work however many taxi cars I want to create. So I think I'm gonna put in a buffer. Buffer like this. Call it taxi spawn. Capacity is -1, so there is no limit to the capacity. Let's also turn on the caption on that one so we can read that this is the taxi spawn. And if you spawn taxis, they will flow onto the garage track. Alright. So when you create a taxi, you want to create them on this taxi spawn. And we're running the simulation from this event controller up here. So I know that the taxi spawn is on the same level as event controller. So then I can say root is the event controller level, root.taxi spawn. And that's going to be fine. Maybe we wish to return the new taxi from this method. I'm not really sure how the infrastructure is going to be in the model, but hopefully I will make some mistakes. So I will get to do some debugging. That's always fun. I'm trying to return, but I need to specify up here that, yeah, this method should be returning an object. So, return an object, I promise. And here, return the taxi. Cool. Aha! I forgot that when we create a taxi, we need to add it to the taxi fleet. So a new row could be the taxi fleet ydim plus 1, and then taxi fleet in the column of the taxis on the new row. Let's put the reference to the new taxi, and the status when you, it's a string, so it's a text. The status of a new taxi could be that it is idle. So which states do we imagine? Idle could be a state, busy could be a state, driving idle, driving busy could also be states. But let's see where this ends up. So create the taxi and add it to the fleet. Add to fleet list, table. Alright. Okay, so in the main frame, now we have the create trams. So I'm gonna go away from trams right now. So I'm gonna put in all that has to do with the tram stuff, and now I copy them again. Oof. Like so. This one should be saved. I'm gonna put these in here for safekeeping. I'm gonna call this frame the archive. So we're creating a new model, we already have an archive. Whew. In it's the taxi control frame. What should we do? We should go into taxi control and create a taxi. How many? Let's do 6 taxis. Create some taxis. Let's use a variable that we can access out here that's more visible. It's gonna be nicer, I think. Number of taxis. Like so. And if we click play, if we go into taxi control, do we have 6 taxis and they're all idle. That should be, aha, spawned in the taxi spawn. And they're driving really close. I think that's dangerous. And they're also driving backwards. Okay, yeah. Should we fix that maybe? Taxis, let's go, you're a taxi. but you need to be rotated 180 degrees. Ah, now they're going downtown, maybe. Cool, we have some taxis. We have the possibility to add requests, and this is the requests log. Let's see if we can run the model and add some requests. How should we test that out? So we will be needing to feed this model with some people adding requests to get on a taxi. So that's not going to happen by itself, obviously. And here is if you have if you're working with a factory in a production system, you usually have an ERP system that is logging a lot of useful information. So if you want to do a simulation project, use this simulation tool to help you improve your organization and production. You're gonna want to go a bit into that data and see like what is the data that we already have on hand, so we could try to feed that into a model like this and see how the model behaves running on that data. But I'm gonna create some fake taxi requests. So taxi jobs. So they're gonna be that someone is calling at a certain time. So let's make this a date, time, and call that column when to call. And then they're gonna ask to be picked up at a certain time. So when pickup. And they're gonna have a location and a destination that they wish to go to. So objects on those two, and so they're gonna have to say, oh, I'm here at the location and I want to arrive at some destination. I want to be picked up. This is when the call should come in. It seems like we're starting on the, can I copy that? That would be nice. So a first call could come in 1 second after we run the model, and they should be asked to be picked up at 6:30. And now we already have some locations here from the tram version I did yesterday. So we have downtown and we have out of town. Let's add another one over here. So that could be, if this is out of town and this is downtown, then this looks like it's side town. Side town, and that's gonna have to have a color of its own. What color do you like? Oh, beautiful taxi. Thank you, Gura. Ah, taxi. Yes, let's make it yellow. Oh, yellow, yellow. There we have a taxi. Let's make it point that way. The text is upside down. Okay. Let's just make it like that. And now we need to reintroduce turns going over there. So I'm just going to draw the roads to get there. So there, you need to really do your job when you create these models. We don't even have roads to go to side town. So we want to come here and go turn right. So this is a right turn. I'm going to copy that and reuse it. That should be connected onto there. Let's go. That works. So we have a right turn. This doesn't align well with these ones. I think they're gonna have to do that. So I'm gonna go into the top view, put it back on there, and then just move it up until it looks aligned. So it's gonna have to go here. And then we take this track and just move it up. And then this one has to follow up here. And then this one is also connected to something. Is it that one that needs to also follow? It's not perfectly aligned. I am going to live with that just to speed the modeling up a bit. Ooh! Looks good enough. And we're gonna want to go straight through this intersection. Alright, and let's go. Come on, come on, come on. Ah, got it. So that should go there. Now we can go straight through. We can go right, and if we're coming from this direction, we would want to be turning left. Do we have a left turn? This seems like a left turn. Alright. Let's put it onto... Ooh, let's snap it in place. Yeah, we got the connector, and it's magically almost perfect. And from either of those, you should be able to connect to that one. So connect the turn to that one, the straight to that one, and this left turn to that one. So now we have 3 connectors here. And then you go like so. This is the way to go to Sidetown. I know it's a bit funky, but that's the way it is. Sidetown is Sidetown. What can I say? Sidetown. Let's put it like so. Is it gonna align perfectly? I don't know. How do they know that the roads align perfectly when they build roads? That's what I've been asking myself sometimes. Okay. A right turn. So we need a right turn here. Like so. And we want a left turn, so copy that left turn and go like over here, turn on those little thingies and move that point so it starts aligning there, and move this up. Ooh. Move that point over there. And then you might want to go straight through. So we also need a lane to do that. Alright. Here we go. There is some small mismatch. That's what you get sometimes. Small mismatches. So is it this one? No? I'm gonna be okay with a small mismatch. I'm gonna be okay. Okay, and a turn, connect that onto there, and this, just shorten it up to here. And this single track needs to be connected to the straight one, to the right turn, and to the left turn. Side town. Taxi request. Taxi jobs. So the location of the person is side town. He wants to go downtown. Okay, let's copy this one. At the same time, we're gonna have someone in downtown that wants to go out of town. Okay. And then we're gonna have yeah, let's see what happens if we do this. So we have from side town, from downtown. Let's also take someone from out of town and have them want to go to the garage. Who's going to the garage? And then from downtown to out of town. Yeah, sure. This is all happening at the same time. And then we're gonna make it happen at 07. Maybe 07. 01 for those two. So now I'm creating data and they are not sorted. So you can see it's becoming 7, 1 minute past 7. I can sort it manually here. Sort ascending. So we're always ascending. It would be nice to put that in an init method to whatever data is in here, always sort it on when to call so that the calls get called in a way that makes sense. Let's see if we can write a script that will make these calls for us. Let's put that on the top level, so somewhere outside the taxi control, someone wishes to use the taxi service. So I'm going to use the method. I'm going to call it use taxi service. And that is simply going to be looking at the taxi jobs and adding these one by one at these timestamps. So I would create a for loop to loop over all the jobs, and this should be called at init. So call at init for I is 1 to taxi jobs ydim. Let's make this a y because it's iterating the y dimension. Makes sense, I think. And here we can, if we want to taxi jobs sort, so we sort the data on this column. So sort on when to call, and it's called sorting it up when you want to sort it ascending, so you get higher and higher values. Like so. So now the question is when to call. So when to call is a date time that we read from the first line. So read that here. When to call on row Y. And now when to call is not going to be when we run the simulation. So we're going to have to wait a bit. So to make this really intuitive, I'm going to do a variable called now. So the time that we have right now is the event controller's absolute sim time, and the amount we have to wait before we make this call time to wait to make the call is a time that is the difference between when to call and now, but of course the other way around, because now is going to be no, when to call is more, it's in the future, so we will be calling in the future, and if you subtract the time that you have right now, then you know how long you need to wait to make that call. Then we can simply wait for the time to wait to make the call. So when you're using really obvious variables like this, you reduce the need to put comments in the code, I think. Could also use with some commenting. So we know we have waited the time. We could put in a little check here actually. So if the time to wait is less than 0, put in a debug. So if this doesn't make sense, the data is not ordered as we expected, put in a debug. Data doesn't make sense. Is it sorted? Then we wait, and then make the call using the taxi service. So then you call taxi control. Taxi control dot, what was it? Add a request. Add request, and here we can see we need to paste in a customer location, customer destination, and when to pick up. The customer location we read from the table. Customer location. And now I think this becomes a long row. It's going to be a bit ugly. So I'm going to do the ugly way, and then I'm going to make it more pretty. So the location, we want to go to destination, and we want to do it at this time. Now if the code would crash for some reason, you get the debugger. It's a bit hard to see the values that you're referring to here, and also the row becomes a bit long. I would almost like to take this and put it as a variable, so the location, we expect it to be an object, and this is the location, and the same for destination and when pickup. Control D 2 times, take that there, make this variable names, and do location, destination, and when pickup. I'm gonna put a breakpoint here, just to show you why I did this. So let's click play. The exit control does not exist. Oh. Aha. Let's remove all the exit control codes that we have for now. Just taxis running around. Nothing happening. Why isn't that perfect code working? Because we're never calling it. So use taxi service, you need to call that one. First you create some taxis, then use the taxi service. So we call that method use taxi service. We don't need to paste in any parameters to this one, so we don't need to put in empty parentheses, but we can do that anyway, just to do it. And here I'm trying to say that when pickup is an object, but that is a date time. So let's reset, run again, we hit the breakpoint, and in this case when we're debugging, it's nice to just hover the mouse over location. You can see the value in the debugger. That's pretty nice. You can also, if you expand this part down here, you have location, destination, and when pickup as variables down here. So you can also read the values in this table. So I think that makes debugging a bit easier, even if it makes the code longer. So it's up to you. Yeah, let's remove the breakpoint. We're gonna add the requests at those times. When we add requests, are we gonna see requests come in here? 3 requests came in right away. Did we expect that? Yeah, 1 second in, we send 4 requests. They're being put here. Cool. Aha! Then they're gonna come in some requests at 7 o'clock, and they want to be picked up before they called. That's not gonna happen, I guess. 7:30. There is something fishy going on. Why can't I write 7? 7:30. Huh. Taxi jobs. Now it works. 7:30. But I want to be picked up. I call it 7. I want to be picked up at 05. So quite soon. And this is also being picked up at that time. Let's say. These are the requests, and nothing happens. But the taxis are very busy for some reason. It's because I simply spawn the taxis and they never get to get any destinations on where to go or what to do. They simply roam free. Sounds nice, but they're not going to be picking up any customers. So I think that if you are in the garage, you're standing by to do a pickup. And if you're standing by, you should not be moving. So when you create a taxi from the start, that new taxi should be stopped. What happens if we do that? You can only stop when it's on a length-oriented object. Aha! So it's being created here. This is not length-oriented, it's more a discrete container of stuff. This is length-oriented, meaning things can move on the path. So then you can stop it. Let's put in a a sensor. You can put in a sensor on the garage. So controls, do a sensor, and put it on the relative end, and use, let's create a method called onSensor. And now we see you got a sensor in the front. Do cleaning. What does that do? It doesn't do very much. Let's rename that onSensor, that stop the taxi on sensor. What happens with the taxi when it stops in the garage? I think it gets the status idle. That's gonna help us. So the taxi is an object, and that's going to be the at. Whatever object triggered the script is at. So that's the taxi. Taxi stopped is true. Someone is banging on the door. Hold on. Whew, and we're back. So how long in are we? We're 1 hour in, maybe 2 hours left, or we're gonna make this taxi work. When a taxi stops in the garage, I think we need to update the status to be something else than idle. So let's do a method for setting a status. So as a parameter, I think we should give the taxi and new status as a text string. And then write that to the taxi fleet. So taxi, the taxi fleet, and remember you're getting the reference to the taxi. It would make sense. Oh, I forget. Aha. Okay, this needs to go. And I can also see that we're adding stuff here each time we start a new simulation, but we never delete stuff here. Okay, so we need to clear this table. And it would make sense to use the taxi as a reference to which row, so I'm activating the row index. So that should be there, and that should be the status column. So when we init requests and taxi fleet delete, But since we are using the 0 column, we need to specifically add that into the range. So we want to delete from this column and down, so from 0, 1, from 0, 1 over to everything else. So if we click play, everything gets deleted and then the taxes here gets added with an idle status. And the sensor doesn't seem to be working at all. On sensor, taxi stopped true. Do we even trigger the sensor? Aha, maybe I forgot to save the code. Now it works. So we're only stopping that taxi, but that taxi is being stopped because it's blocked by this one. So, much like a taxi queue. Makes sense. Alright, the taxis. Where are we now? We have a taxi fleet. They're all idle. If you stop on the sensor, update the status of the taxi. So go into taxi control and use set status. Set status for that taxi. Okay, then taxi fleet, that table looks like this. The column is called status, so reference status and use the taxi itself as a reference to the row and set the new status to be new status. Alright, so the new status when you hit the sensor for this taxi should be idle. Cool. New status is idle. So the other taxis in here, they're behind in the queue. They're not going to be idle yet. Let's see what happens. They're going to be idle from the start. But maybe you don't want that. That all taxis should be idle from the start. No. So when you create the taxis, don't set any status. So why doesn't this work? Unknown index in the taxi fleet. Aha. Classic. We're all writing to ydim +1, but the ydim never increases because we're not writing to status. So you need to use the ydim index when you create taxis. So ydim index. Then it should be working. And now we're getting into debug mode because stuff starts breaking. That's good. Oh, you can't see my event controller. Let's put it up here. Now I'm curious. Now I think only the first taxi should be idle. Taxi control, taxi fleet. Only the one hitting the sensor becomes idle. Okay. That feels good, I think. So where are we? We are adding requests. We are setting the taxi is calling, setting its status. Now I think it's time to be able that we can match a taxi when we get a request. Yeah, so we can get a taxi. So get idle taxi. It would need to retrieve one who is idle. Okay, and then return that taxi. So return an object and go into the taxi fleet table, set, we want to search this column, so we want to reset the search, excuse me, we want to search this table, so we want to set the cursor, set cursor, column, row. So you set the cursor on the column status, and don't be scared because this is a small s and this is a capital S. This scripting language doesn't care. Column, and set it on the first row, so that it's like resetting the search pointer in the table, and then we search. Is it search or is it find? Find. So we wish to find in a range, so we can say I'm looking for in a range. I want to find the value idle, and this range you specify by saying look in column status, but look on all the rows, so star for all rows, and you find the thing that you're looking for. But what does find return? Find returns a boolean. So if it finds it, it's gonna be true. So if you find the taxi is gonna be out here, so the row that you find it on, the taxi is there. So an idle taxi is found on taxi fleet in column taxis on the row where we hit idle, and that is going to be cursor y. So the y dimension of the cursor is going to give you the idle taxi, and then you return the idle taxi, and if you don't find, I guess you return void, means you will not find an idle taxi. That was to get one idle taxi. Then we could also have assign a request to a taxi. So the parameter would be that this taxi taxi object gets to handle the request. Should we put a new column with assigned taxi to a request? Makes sense. So assigned taxi object in requests, assign request to taxi, remove this, parameter taxi object, and I'm thinking of how to reference the request. What we could do is when you assign a request to a taxi, that means that you know that you have a request and you're assigning it to a taxi. You could simply reference the row here. So let's try that. So we're gonna paste in the request row as an integer, which means that assign this request on a row to this taxi. And what does that mean? To me it means that you have the requests, and that requests the assigned taxi on which row, on the request row that we specify, should now be this taxi. So now the requests can see that they have an assigned taxi. But we also want the taxi destination to be equal to the customer location. Makes sense? Like so. So then the taxi will drive to the customer location. And then the taxi is not stopped. So stopped is false. Start the taxi, like so. Alright. Assign a request, get idle taxi. So when you add, every time you add a request, you should let's think about this. Here I think it becomes a little bit trickier. So you have a request to the taxi service, you add it. Of course, if you assign the request to a taxi, it's going to start right away. Do I have any tips from you in the audience? Are you following along? So we're adding requests. We want when pickup. Yeah, let's try this. That we assign the request to a taxi. That we call that method when pickup. But that means the taxi is going to start at the time of the pickup. So we're gonna do that, which means that all customers are gonna be picked up late. So this is if you schedule the assign request, it looks like this. So assign the request to taxi. Assign request to taxi. We're not going to paste in the taxi here. We're actually going to use get idle taxi. And just hope that we're going to have an idle taxi. So the taxi is going to be get idle taxi. That doesn't take any parameters, no. And here I put in if taxi is void, debug, no available taxi. What should we do? And this is sort of the really tricky thing when designing any system is that you're most likely going to run into the situation that you're trying to build a logic that's always going to work. But we know from experience that if we add many requests at the same time, there are going to be no idle taxis. And then taxi will be void, in this case. What should the model do then? So programming it like this sort of gives a way that we know we could run into issues, but at least we're getting some help from the programmer in this case, that when we don't find an idle taxi, we could foresee that that could happen. No available taxi. What should we do? So it means we could see that it was going to happen, but we put in the question. And I like to do this because when I run into my own debugs like this, I can sort of see, oh yeah, I was trying to help myself back in time. This man looks like he can't click heads in CS. This is hitting really close to heart when you say that. It was a long time ago since I played Counter-Strike. I played one game a few weeks ago. Before that, I think it was during Christmas or something. But I just want to say, I have a really good looking AK-47, and I wouldn't mind giving CS game a go. Okay. Taxi. Requests. Where were we? I was talking about Counter-Strike. I got sidetracked. Yeah, we get the taxi. Yeah, let's just run the code. I don't know what's gonna happen. I don't know where we are. Ah, this row is not finished. Assign request to taxi. What do we need to throw in here? The request row. And that is probably the new row. But we need to schedule this method call to when the pickup should be. How do you do that? Assign request.schedule. I always forget this. Schedule a method call. Schedule. Let's just write schedule, click F1. I should be heading into some documentation. Schedule. SimTalk, shift calendar, schedule. No. Self annotations. It's not schedule. What are you modeling right now? I am trying to model this. Ta-da! Which way is it? Is it that way? It's that way. This is obviously a city, and each colorful little square is a destination in the city. So there is a garage in the city, and we have downtown, and we have out of town. Oops, that is outside the city. So we have out of town, we have downtown, and we have side town. And I'm trying to model a taxi service that we can put requests to the taxis, and seeing that happen. So right now, if I click play, I get some taxis, and they're stopping because I have a sensor. When they arrive at the end of the garage, before they exit the garage, the taxi is stopped, and the first taxi that hits the sensor is being set to idle. Alright, and now I am trying to get to the point where you can add requests to the taxi systems, and the requests look like this. That you have a customer location and a customer destination, so you want to go from side town to downtown, and you want to be picked up at this time. And the assigned taxi should be popping up here when there is an assigned taxi. So that is where I am right now, and the data I'm feeding to use the taxi service looks like this. It's called taxi jobs, and I imagine that the taxi jobs has a time when to place the call to the taxi service, a time when the customer wishes to be picked up, from where location, and they want to be driven by the taxi to a destination. So that is how I imagine that. And then the code use taxi service will simply loop over all the made up taxi jobs that I made up here. It's going to see when to place the call, and it's going to do a delay to place the call, and then it's going to, when it's time to do the call, it will make the call, and it will add the request here to the taxi control. And as I said before, when you add a request, I will assume that we can always accept the request right now. So there will be no rejection when you call this taxi service. It will always say yes. Let's close that one, and that one was apparently red. It's red. I made a mistake. Thank you, Life Outdoors. Now I am back where I was, making some mistakes here. Does any one of you ever model in Plant Simulation? Do you know how to schedule a call at a specific time to a method? I know it's possible, but I just forgot. So what I want to do is I want to schedule this method call at a specific delay or time. So assign the request to taxi dot. You cannot do dot. How am I gonna find this out? Assign dot. When you add the and then it becomes a reference to the object and not a method call in itself. And that makes the dot work, which is giving me more suggestions. And this is going, let's put it up here. I'm looking for a way to schedule this call later. Should be here. I just forgot. Delete. Is it method call? Oh, execute. Execute in, or execute new call chain. So execute in, you can call it at a specific date time. So execute in, execute in. So I want to execute this in when pickup. That is the date time I want to use. And then you can fill in with the arguments to the method. That is only taking in the new row reference. So that should, so I'm gonna write schedule method call later. And we know that it's going to be scheduled too late, but we're gonna live with that for now. So let's see, when you assign, you get the request row, and then you start the taxi. I'm going to put in a breakpoint here, and let's see if we're going to get some taxis moving. Am I starting the taxi? Yes, I started the taxi. Okay. And now it's 6:30, when the first customer is supposed to be picked up. You get a request to a taxi, and it stops at the breakpoint. Let's go! Continue! And another one. And a third one. And a fourth one. Ah, and here is where my taxi system breaks down. But the first request was for the taxi here. Let's see if that was the first job. The first job was to go to side town and then deliver downtown. But he is heading downtown. Is he actually doing the fourth request first? Seems like it. And all these requests that we have so far in the system all got assigned to the first taxi. That is no good, because it can't be going to 4 places at the same time. So we need to fix that. And I think here is when we get an idle taxi. I forgot to set the state. Assign this request to this taxi. So the set status of this taxi, set the status of this taxi to be, I'm just gonna say he's busy. Let's see how that works for us. So the first taxi got the job. He is destination side town. The next one, you hit the debug. There is no available taxi. What should we do? And that is because the taxi fleet, one was busy, but you need to hit the sensor. You need to hit the sensor to become idle, which is no bueno. So I think you should actually become idle as soon as you enter the garage. So enter garage, this one, entrance, enter garage, and when you do enter, you just update the status to idle. So if we just start the model, oh yeah, we don't have a taxi. So the taxi is the @ symbol. So all the taxis go in, they're idle, and the taxi fleet, they're all idle. Let's see how this works. The first one will be set to busy, and the next one busy, busy, busy. 4 requests, 4 taxis get busy, but probably only one will drive out because they're hitting the sensor, and the sensor is always stopping them. So we're gonna do this, that, yeah, we don't need to update the status here. So if the status, so the taxi fleet, taxi control, taxi fleet, if the status of my taxi is idle, then you can stop. Stop taxis without jobs. That's one way of doing it. Let's see if that works. So right now all my taxis are idle. Here, let's go. Now that we're getting 4 requests, 1, 2, 3, 4. 4 become busy. This one has a destination to go side town, downtown, out of town, downtown. Is that according to the requests? The taxi option we defined was to go side town, downtown, out of town, downtown. I think that makes sense. And then we have taxi 1, 2, 3, 4 assigned to the jobs and not the same taxi. These are still idle, so they stop at the sensor. And the taxis are being directed to go to their destinations. And then they just go haywire because there is no logic yet what to happen when they get to side town to pick up the person. So user objects. Let's create a customer. So we can have a customer waiting, being picked up, and visualize that. So if you're ever showing this model to anyone, to make them understand that now the taxi is empty, no customer, and now it's loaded, let's create a customer. So duplicate that part, call that part be a customer, open in 3D, exchange graphics. Do we have a worker, Jack or Jill? Jack or Jill? Let's do Jill. Alright. So we have Jill. That's a customer. And how should the customers be waiting? Let's make a simple buffer queue. So this is going to be side town customer queue. Alright, captions, turn on the captions so we can see what we're looking at. The side town customer queue. Nice. And then we have the, of course, side town. This is downtown customer queue. And up here we have the garage. No customers want to go from the garage. And we have out of town customer queue. Okay. And since we used a naming of these in such a nice way, we should spawn a customer to wait here when the customer wants to be picked up. And in this model, it's when you call the assign request to taxi. So the customer, just drag the customer into the code. Create a new customer on the so we need to find a reference to the correct queue. The customer location, I'm going to put this in a variable instead. So the customer location object is going to be either downtown or it's going to be side town. So we can use that when we're searching for the correct customer queue. So the customer queue object should be the root, and you want to find the node with the name of the location, the customer location name plus underscore customer queue. All right. I think this is gonna work. So the customer queue, you want to create the customer on the customer queue. Now, if you have many customers waiting in the same queue, how do you know that the taxi actually picks up the right customer? What to do? Should we have a request ID? Should we have a request ID and that customer gets the request ID? Let's not bother for now. It would make sense that when the customer calls, you assign that transport job some sort of ID connected to the customer, so that when the taxi arrives, it will pick up the right one. But I'm not going to bother today. Maybe that is implementation for future. You spawn the customer in the customer queue. So spawn a customer. Let's do that. And if we run the model, you get 1, 2, 3, 4 requests. You have one inside town, looking good. You have 2 downtown. Of course, downtown is more busy, so they're standing on top of each other. That makes sense. And then you have your out of town customer. And I think we need to put in a sensor on each of these locations. So when a taxi arrives here, it's going to pick up the customer. So on sensor, I'm going to call it pickup sensor. And where to place it in a good way, because I want to use the same sensor on all of these. So new sensor on the relative end, control pickup sensor, like so. And the same here, we have a pickup sensor, do a new at 0.99 of the relative length, call pickup sensor, and the same here, new on relative 0.99 pickup sensor. Okay, pickup sensor code is here. Write debug just to see if this gets triggered. I'm going to remove the breakpoint here. And now we're at the pickup sensor. We can see that in this case, in the anonymous identifiers, it's being called from out of town. So we are now out of town. So if we react to where we are, we can simply use that to find the correct queue and pick up that customer. So where are we? Our name. So reference to the customer queue object. Customer queue, I'm talking about this blue one, is going to be question mark dot name. Question mark is which object triggered the sensor, or which static object, not an MU. The MU is at, but this is the track. So the track name downtown. So find it by root node question mark name plus underscore customer queue. That should be it. And then our customer must be the next one in the customer queue. So the customer object is the customer queue dot cont. So if you have something in the queue, the cont is going to be the next one that wishes to leave the queue. So in a FIFO queue, that is the same as the first one that entered. So we can put in, if there is no queue, if the customer queue is empty, debug. Why would taxi drive here if no customer waiting? That's what I wonder. That's what I wonder. The customer here, and let's move the customer into the taxi. Customer move, and the taxi is the at, so move onto the taxi like so, and this move could fail, so if not move, debug. So we're always going to call move, but if that returns false, we get a debug. Why can't the customer move into the taxi? Is it full? Okay. Let's put a debug here. Zoom out and run. We're hitting the debug. And where are we? We are out of town. That's up here. So this is the first one that arrives. Let's slow down and continue. Way! We have a customer in a small taxi. Ah, the taxis get flat. No. Oh, we have flat taxis. And we have very small taxis. Something fishy is going on. What squeezes the taxis? Scale automatically, probably. Probably these roads are really short for big taxi cars. Let's see here. Taxi, 3D options, do not scale automatically. Okay. Then they are a lot bigger. And now we have the customer. Now their scales are correct relative to each other. So we can see that someone is riding in the taxi, a visualization that we have picked up the customer. That's going to be valuable as we are debugging the model, as it becomes more advanced. We can see what is going on. So that's good. Let's remove the breakpoint. Let's go. People are riding the taxis in our beautiful taxi service simulation. Now the question arises, why would the taxi drive here if no customer is waiting? Well, that is because you're not always picking up people. You could also be dropping them off. But when you're dropping them off, so it's not going to be only pickup sensor. This sensor is going to be used to drop people off also. So there could be two cases. The taxi, let's get the taxi first. So the taxi. So if the taxi is empty, then we do pick up. Else drop off. And this was the code we used to do pickup. And this is the code we're going to write to drop someone off. And the way we do that is, let's put in a drain somewhere in the model. And the customers will be put down the drain. Drop off, let's wait 60. So even if you are empty, if you want to drop someone off, you wait 60. If you want to pick someone up, you wait 60. You drop them off. And you move them to drain. So the taxi can't move to the root drain. And the taxi can't is going to be the customer. So if we want a little code that is easier to read, we say that the customer is this, and then move the customer to drain. That is do drop off. Cool. We also need that when we do the pickup, we have arrived at the destination, set the destination of taxi to be where the customer wishes to go. Alright. Where the customer wishes to go. And that we should probably be able to read in a table somewhere. So when we're here, we need to look into where does the customer want to go? This is an issue because we're not keeping track of which customer we're picking up. We only know that we're at a destination, and we don't know what the customer wants. So we don't know where to drop him. We cannot find that reference. So we need to take a little bit more care when we add requests to the requests table. So this is a request. Can we do an ID? And that ID is going to be let's put in an ID. Should it be a number? Yeah, sure. ID number. The ID is going to be the row that is being put on. So this is going to give unique IDs if you never clear the requests table. which you might wanna if the model is big and clumsy. You might want to clear the tables. Oh yeah, nice animations. Thank you, thank you. We are getting there. And we... where was I? The customer ID. The customer ID. Add a request. You get the ID. You assign a request to a taxi. You create the customer here, and then you let's assign that this customer dot ID is equal to the request's ID that you get here. So the customer ID is going to be the ID of the request row, and then you write that ID to the customer. So it could be that you ask the customer, what's your name, sir? And they say, my name is John, and then you know that you need to go there to pick up John. Very good. Now the customer is not going to have an ID, so it's going to crash. It's not going to have an ID variable. So it crashes here. You cannot assign a value, of course, because the customer here, you can put in a custom variable as an integer, call that ID. That is already protected variable name, so let's call it underscore ID. And the underscore ID of the customer will be the ID. Yep, okay. So big taxis, small roads. This is what you get sometimes. And now you're out of town, you're up here. The customer is in the taxi already. We're waiting 60 seconds to simulate some sort of time that it takes to stop, getting the car before you start driving. Now we need to set the destination of the taxi. And if you double click the customer, it has the ID 3. Yeah. Should we maybe do this in an even nicer way, that the customer knows the destination that he wants to go to? I think so. So here you customer ID, customer dot destination should be read from the requests table at this point. Customer destination, like so. So the customer keeps track of where he wants to go. And now we're back, we're out of town, the customer is here, and the customer knows he wants to go to the garage. I don't know why I put the garage. I don't think that should be a valid destination. Anyhow, then we can simply say that the taxi destination is equal to the customer destination. Taxi destination is the customer destination. Do we need to start the taxi? So taxi stopped is true and taxi stopped is false. So start the taxi. Hey, very fun to follow you along. It would be interesting to see your approach on how you would create statistics and results for this model, and some references on how you usually do it in production. Yeah, statistics then. That's going to be the next thing that we want to get. So I'm just going to finish this real quick. Start the taxi again. Let's go. Reset. You wait 60 seconds. We single step. Let's put the breakpoint here instead. Okay, taxi destination from out of town. It should be going to the garage. I'm gonna change that so we don't have any requests to go to garage. We should go from out of town to side town and from out of town to downtown. Okay, let's go. Because I didn't put any sensor on the garage for it to make sense. I want to keep the garage a bit special. That's my special taxi place. The destination of the taxi is now side town. Let's see if it goes to side town. Skip the breakpoint. So we're going to follow this taxi. Does he go to side town? Oh, he is inside town. Darn it. Nothing happened. And the customer is now in the garage. Ah, it doesn't work. The pickup sensor. If taxi is empty. Else, you need to stop the taxi. So what is the taxi? Taxi. Taxi stopped. I think and I hope that this was the issue. Put a breakpoint here. I forgot to stop the taxi, so it just kept running. Aha. Taxi is stopped. Another taxi is stopped. And another taxi is stopped. And what's going to happen when the customer after 60 seconds disappear? Another taxi is stopped. Yeah, so the customers, they disappear. That's fine. So after you drop someone off, I'm gonna say that the taxi destination is going to be the garage. Like so. One, two, two, two. Like so. Two, two. Okay, so they drop the customer off and then they go back to the garage. I have deliberately not fixed this, that they're running into each other yet. I need to increase the size of the object. The reason I have not done that is that it's gonna make my garage too small, and then I would need to increase maybe the size of all the roads to make more sense. So we're just gonna live with the taxis running into each other for now, just not to spend time on that. The next thing is statistics. So it would be interesting to see your approach on how you would create statistics and results, some references on how you usually do it in production. References, I cannot really show other models that I'm working on professionally, so that is why I'm doing this stream just by freehand. But I can show you how I would do it, or what I would like to see. You can, of course, if you're used to working in Excel, you might do calculations, and then it's easy to stop at, like, what is the average number? Let's say, how many pickups do they do? Yeah, they do this many pickups. But I would collect statistics maybe hourly. So what I would do is that each time something happens to the taxi, let's say, because it seems like we're on the side of the taxi service. We have been called in by the taxi service to do this simulation, so they wish to know expected this order list. When given this order list, these taxi jobs, how will the taxis perform? I would simply have each taxi send in a status update each time the state changes. So when you're going from busy to idle, I would say that I am now busy at this timestamp. And then I would say, now I am idle at this other timestamp. And that means you're going to end up with statistics that you see exactly the point in time where it went from one state to the other. And then you can treat that data as you want. Do you wish to see an hour by hour statistics? Then you can get that. So yeah, I think that makes a lot of sense, that you can so I would have each individual taxi. Let's see if we can do this. And that is going to, if I am able to do that today, it's going to conclude today's streaming session. I really like the feedback and the input, because it gives me some direction on taking this into a valuable place. So statistics. Alright, let's go into taxi control and do some statistics. Taxi fleet. So I'm gonna imagine that every hour we log the data that happens for every hour, and then when the hour is over, we flush that data into a bigger table, and then we keep track what's happening during the hour, and then we flush that data into a bigger table. So then you're going to collect hour by hour statistics. I hope it makes sense. Like so. So data table. So then we're going to have a period, and this is the hour. So period stats. We can put in a variable to say how long is our period. The period for the statistics, the smallest period, is going to be 1 hour. 3,600 seconds, or where is the time? The period is 1 hour. Then after that, this statistics is only going to be statistics for 1 hour. Then we grab all of that and flush into the big statistics table. So we have the period, and then we have the simulation stats. Maybe maybe we can do an arrow. And sorry, my voice is not used to speaking this much. Can we create an arrow just to make it? That's an arrow 0.6 in scale. It's a cone, but it's an arrow. So we want to flush the data from up here down to the simulation stats. So the period, what we need is each taxi to be here. So the taxis. So when you create taxis, create taxi, you're adding them to the taxi fleet, but you also want to add them to period stats. Period stats. Taxis, taxis. So you put the taxi here, and so each taxi is going to be period stats, taxis. Why don't I see the taxi? It's because I didn't save the method. So period stats, each taxi is going to collect statistics on states. We could measure how many pickups. So I'm going to do one column for state busy, one for idle, and one for pickups. Pickups is going to be an integer. Busy and idle are going to be, I want to list it as a real float number. It's going to be seconds spent in the busy state. Alright, so set status. We're going to have an old status. So the old status is going to be the status of the taxi. Old status, set status. So the old status, we can read that from the taxi fleet status. And we wish to, so let's say we're changing the status from busy to idle. If we just keep track of the timestamp of when we last changed state, we're gonna always have the old status and the timestamp of that. So let's prepare the taxi with a custom variable, call that state changed timestamp. Make that time, state changed timestamp. So the state changed timestamp in the code is the taxi. The taxis.state. So we know that the old status was set at this time. And then we want to find out how long has it been in this state. So the state duration is simply going to be now. So the event controller dot sim time minus when we switched state the last time. We do it as a real. So the duration of the old state is now here, and this we wish to record in this during this period. So the old status, so period stats, period statistics for a taxi, for, no, busy idle pickup. So the old status, it's the old status, that one or that one, on the row of the taxi is going to be plus equals that state's duration. So I call that we accumulate state duration here. And then we just going to set the status of the taxi to the new status. But before we set the new status, we always accumulate the state duration of the old status. And because we're setting a new status, we need to save the timestamp. It doesn't make sense to make this a variable. Let's put that there and remove this row and say that the timestamp for when the state changed is now. Like so. If we just run now, what are we gonna see? The old status is an empty string. Okay, fair enough. If old status is not an empty string, then it makes sense. Something happened. Did we hit a debug somewhere? Or was the model simply done and happy? Everything seems to have been run. And we can see that it's been recording more time here than we defined as our period. And that is not good. So that we need to fix. And then we need to add the pickups. So counting pickups, how would we do that? Pickup sensor, drop off, pickup. So we're doing a pickup. Let's go into taxi control, period stats, and count pickups for this taxi. Plus equals 1. If we reset, run that code, we should be getting pickups that all the 4 taxis have done 1 pickup. During this time, and each time we run the model, these numbers never get reset, so it just adds more and more. So we of course need to period stats. Period stats, we need to delete the table. Now it was cleared. So we reset, we run, it's being reset. Like so. And now there is a small piece of logic missing. So when these are adding up to exactly a period of time, you flush the data over to simulation stats, and then you would be grabbing all these 6, putting here, all these 6, and for the next hour, and then you reset this table, and then you write for the next period, all those 6 down here, and you keep doing that. And then you will get a nice long log where you can follow each taxi. You can export it to Excel if you want to play in Excel with it. You can filter on, maybe you only want to show one taxi, or whatever you want to see. You could do it in here also. So where am I? Taxi control. So you're writing statistics here, but then you want to flush data. So flush period. So after the hour, you want to flush the data here into here. So this is the table, simulation stats. So you will be grabbing here row by row. How to code it? Simulation stats. So for each row in the period stats. So y is 1, 2, period. Or maybe you could just copy the range over. So I always... Thanks for today, Life Outdoors. See you around. Thanks for watching. Any feedback? Should I talk more slowly? Should I have better lighting? Better microphone? You wish to see something else? Just let me know. Flush period. Then we do the period stats. Dot copy the range. Copy a range to source range to a target table. Source range, we want to go from 0, 1 0, 1 over to pickups, and then 6 rows down, but that should be the YDIM. YDIM index, then we use how long this column is. YDIM is for all the other columns. All good. Keep it up. Woo! So we copy this source range into a target table. That's going to be the simulation stats. Simulation stats table. The target column. Is going to be... we don't want to use the... So the first, it's going to be the first column. And the row is going to be this row plus 1, I think. So if we just make some dummy data, you open this table that you want to copy stuff to, and you run this code manually by F5, then it gets flushed in here. Press F5 again, it flushes more data over, and F5 again, more data. This is now a string reference to the taxi. That's alright because it's only statistics. You don't need to access the actual object. So string here is fine. These could be reals. and number of pickups could be set to an integer. Real, okay, and then this one integer, all right. Reset, so also simulation stats need to be reset when we start the model. And it doesn't like that. We can just do this. Okay. So you run. So flush period. This does what it's supposed to, but how often should it do it? It should do it exactly after the period. So we can put in a generator, or a trigger, or a generator. I think a generator. Ah, the generator requires a professional license. No! Then we code the generator ourselves. I just want to trigger a flush period every period. So it's gonna call this generator for the period. Alright. And it's going to while root event controller run active. Okay, let's just do while true. While the simulation is running, but I don't remember it's in the event controller. While true, you wait for the period, and then you call flush period. That's a very easy little code. And then the init must be calling the generator. Call the generator. And now there is one little thing. So we're getting the stats thrown over every period. So the simulation stats, of course, we need to remember which period was this and which period was that. So let's put in some headers here. Period start. And this is a real. And this is the period end. So it's going to start, the first period starts at time 0, and the period end is going to be 3600. The next here is going to say, it's still the same period, so it's also going to be 0, 0, 0, 0, 0 for these ones, up to an hour. And we're also counting the periods, so period number. Period number is an integer. That's what I would like to see. And then these headers should be these headers. Period start. So when you And now I realize why I don't want to use the copy. Because I don't want to copy the exact values, because these are not going to be corresponding to the exact breakpoint of the period. So we want to do it row by row instead. So let's remove this. So period stats, widen, do we want to get a reference to our taxing? Period stats. Okay, thanks for the fast switch of topic. Ha, cool approach, definitely. I am currently trying to figure out the best way to write statistics. I usually have a logger, which then just collects timestamps, which you then need to process afterwards with Python or whatever. Also, I'm really considering starting to use SQLite since exporting to Excel is hell. Yes. I mean, the way that you do it is also an approach that I use. You simply log the timestamp, and that's it. And then you can, if you want hourly data afterwards, you can just write your Python script or SymTalk script to get that data for you out of that raw data. But I think having it like this, that you can say, I want to see statistics every hour, or I want to see statistics 15 minutes by 15 minutes. You can just change that here and the simulation will record that for you. I like that approach. I think it's quite nice. Of course, your approach is nice because it leaves more creativity open to bring it into Python and treat it there. So I guess your approach works pretty well. And yeah, exporting to Excel, it is what it is. I never export to Excel, actually. If I export the table manually, I usually export it as a text file. So you can go in here and you can set the separator that you want. Tab usually works, or a semicolon or whatever. Which decimal separator you want, and the time format, if you have timestamps. And then you click export to text file, put it on the desktop, and then you get it in this form. And text files and CSV files, I think, are a bit quicker to output than to output a big Excel file. So then if you want, you can parse this into Python instead of the Excel file. So that's an alternative to using SQL or SQLite. And where was I in the statistics? Yeah, the period stats. I'm gonna get a reference to the taxi. And yeah, don't forget to follow and subscribe, or what do you say? Like and subscribe. So how would you do this? I don't want to think about how to do it. I'm gonna put in a breakpoint, run the code, look at the data and see what we have. So the time should be 1 hour in. It's exactly 1 hour in. We have reached the time where we want to flush the data. And the data looks like this. So this doesn't add up to 3,600. It means we're missing some time, and that is because we have set the time, but then we have not set it since, and now it's time to flush the data. So we need to add here. What is the current state of this taxi? And that you can read from the taxi fleet. Current state is idle. Okay. So current state is taxi fleet. Was it state or status? Status. Okay. Is the status of the taxi. That's the current state. Yeah, this is gonna work, I think. So first we want two period stats for the current state for this taxi plus equal the current state duration, and we don't have that yet, but we do have the taxi, what is it? We have the taxi, this variable, the last time that it changed. So the current state duration would be equal to now root event controller dot sim time minus last time it changed. You add that to the current state, and we reset this to be now. So we flush the data. So the first thing we're doing here is we're updating period stats. We're finish this period. And now we write the data or flush the data over to big table. And now we can use this approach, probably. But we don't want to copy all the rows, because now we're doing in a for loop where we're doing it row by row. So here we want to... I don't remember what this was. You are going from 0, 1. So this is from 0, 1, all the way down here. But I want to go from 0, 1 over to only here. So not 1, but I want to use Y. So this row, and I'll go all the way over to pickups on this row and copy that into that table on a new row. I think that is going to work. Let's try. So we gather all this stuff and we get a crash. Ooh, the taxi is a reference to the period stats table. No. Period stats taxis on that row, actually. Like so. Let's reset, run again. And now we know it's 1 hour in, we want to flush all the stats. Darn it. Put in a var. Reset, run again. And the current state duration is 25 minutes. So we're adding that to that. And now these two should hopefully add up to be exactly 3,600. And the big table, we should be getting stats in here row by row. row by row. And why is this? Ah, we're copying that into that table. I'm doing something funky wonky. Funky wonky. Taxis are objects, but we should be pasting them from column taxis and forwards. So paste them into not one, but the column called taxis and forwards. Taxis, simulation stats, like so. And one row, we get the data over here. Good. 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 And what will happen with the ones who have not done anything? Nothing happened. And that is no bueno. Because let's use the wide index here. So we get all of them, hopefully. 1, 2, 3, 4. I don't like what I see, but let's see what happens. This doesn't add up to 3,600, so something is off. And that is because I know why. So let's take these times. These should, in my view, add up to 3,600. So let's use our friend Excel. Can it add those two? No, they cannot, because we have to replace the dot with a comma, unfortunately. And this is the sum of whatever is here. That one works. It only works for the first one. The other ones doesn't work. And that is because when we are creating the taxis, we're not setting the state. We're only setting the status when they're approaching the sensor. We're only setting when they are entering the garage. That takes some time before they leave the initial buffer. I don't know if you remember here. You have that one is getting the state, and then they are getting the state one by one. So I'm gonna actually, when you create the taxi, I'm gonna set the status of the new taxi to be idle. And if you just do that, I think it should work. So now there already been a bit of idling before they enter, and that should be the missing link here in this case. Let's go. Your 1, 2, 3, 4, 5, 6. Let's grab these numbers, put them into Excel instead, and you do replace. And now we can see that the times are adding up to 3,600, which is the period. So now we're happy, now it works. And after we have flushed all the data, we reset the period stats. And we can probably find that code here, just copy it over. Period stats, just clear that table. Yeah, but we don't want to remove the taxis, so not start from the 0 column, start from the first column. So when we get here, do a breakpoint, check that it works, reset, play again. Now we're here, we have flushed the data beautifully. We do this line, we save the taxis, we only delete the data for the hour, and then we're good to go. But we're still missing this over here. So that would be that the first hour, I would like that it says the period number here. We can do a calculation, of course. Maybe that would be fine. So period number integer is going to be the root event controller's sim time divided by the period length, the period. So if we run 1 hour, you divide it by the period of 1 hour. I think the first period number should be 1. When you run it the next period, you divide it by the period, you get period number 2. And using that, we can calculate the period start and end. So the period start should always be now minus a period, and the period end should always be right now. And the period number is an integer. The other two, I want to treat those as reals, like so. And let's see if that is all that it takes. I calculated the values, but I forgot to write them to the table, and it doesn't make sense to do it every iteration of the for loop. We can do it out here. So calculate period numbers, and then in the simulation stats, you know that the period start, on this row, it's going to be the ydim, should be the period start, and then we're going to have end and num, period number, I'm going to call it num, so I have the same, num, end, and that should be it. What is you doing? Yeah, that is a good question. You are now almost 3 hours into creating a taxi service simulation where the taxis are driving downtown, and they're driving out of town, and they're even driving side town. Let me show you. So this is a road network. Here you can go downtown, you can go to the garage, you can go out of town, and you can go to side town. This stream is almost 3 hours in. It's gonna be saved so you can rewatch it later. So please do that if you're interested in all the details. But I can tell you, what I can tell you that we have is some taxi cars. Sorry for them being knocked into each other like that. There is an explanation to it. And then we get some customers being picked up down here. So a customer is inside this taxi, and then they are being delivered to the destinations they need to go. And after a taxi is finished with delivering a customer to its destination, it's driving back to the taxi garage. And here is the data. I just imagined some taxi jobs. They look like this. You get a time for a call when the customer calls. They say they wish to be picked up at some time, and they are now side town and they want to go to the destination downtown, let's say. So this is the in data for feeding this model of doing this taxi service. Yandley, is it Yandle or is it some completely unknown? I don't know. Now, where were we? I got a question on statistics. How would you collect statistics and approaches to that? So my approach in this case would be, since we have 6 individual taxis, I would like that each taxi records when it changes state, and that you log how long the taxi has been in the previous state. And then you flush that data every hour, so you keep track within the hour of what's happening in different states, how many pickups one taxi is doing. And then you, after 1 hour, you flush that over in this big table, and you reset the small table like so, and then you're ready to go another hour. Let's see it head into 2 hours. Now we're at 2 hours. We have recorded some more statistics on what was going on, and that should be moved over into the big statistics table, so we can see this was the first period, this was going on for each taxi, it was busy a few seconds, it was idle for a few seconds, and it did 1 pickup. The next hour, no pickups, it was busy driving a little bit, and then it's been idle for a long time. I think I am forgetting to switch it into the idle state correctly, but that is for a future stream. But this is how I would do it to collect the stats, as a suggestion. Anyone else have any suggestions? So we do that. Let's go. And the stats, after 1 hour, we flush the data again. And then they have all been busy. That's not correct. So because they're standing still in the garage. So I need to fix, maybe I can do that as a last thing. I need to fix the updating of the state. So the destination is the garage. So I still think that after the taxi drops off the customer, that it's busy. Because right now the system cannot handle a taxi being idle while out on the streets. So that would be something to add here. The garage, but you enter the garage and then you set the status to idle. And then you update this timestamp. Why is it being busy? The taxi fleet, they are now idle. Oops. Now 4 are busy and 1 is idle. Busy. Let's see what happens when they drive around. They're busy, and then they're picking up people. They're still busy, and now they're gonna start to drop people here. Now one is in the garage and he became idle. Now those two are in the garage and they are idle, and one is still busy and he should be going idle, and they're all idle, and we flush the data. Period stats. Okay, I think it's something with my calculation when you flush the data. Because, no, they're busy. Why are they busy? 4 of them are busy. Is it because they got a new assignment maybe? Yeah, there are still loose threads and things to be fixed. I can see they're standing still. It says they are busy. I don't fully buy that. But now I'm up to 4 viewers, so I sort of feel that I cannot really let this one slide. I was going to, because in all honesty, simulation never gets finished. But I still have maybe 10 minutes, 20 minutes, so I should be able to find this bug. Now the question is, why does it say that the taxis are busy when they're obviously standing still here? So let's see. So the first period should be flushing. 1 hour in. Let's do that. Okay. Now we are 2 hours in, and now it says they are busy. If the status is idle, you stop them. Okay, let's do it again and think. They are all idle after 1 hour. You flush the data, and now it's starting on the 2nd hour. They're still idle. It must be a job or something. Now 2 of them are busy, a little bit after 7. But they are not the ones. Aha, they're busy. So it always goes from the top and selects taxi 1 first, and then it selects taxi 2, and then it's trying to start that taxi. But that is not really a good approach, because taxi 1 is not the first in line. We could fix this by code, but maybe we want to select the first taxi in the queue that also matches the state idle. Let's try to do that, and when I fix that, it's time to wrap the stream up. So what did I just say? I think I figured it out, but now I forgot. That happens a lot when you do these models. You hang on by a small thread, and you know what to do, and then you start thinking about something else, and the thread is lost. It was the taxis. I figured out why they were giving faulty statistics, because when you get an idle taxi. You only search for an idle one in the table, but you want the one that is idle, that is the furthest one ahead in the garage. So how could we do that? We could iterate over all the taxis inside the queue, I guess. So if it looks like this, pause it, and we're gonna replace this code. So for I is 1 to root garage number of MUs. So this is a counter keeping track of how many MU objects are on the path garage. So a taxi. So a taxi is going to be the garage MU on index I. And now I don't know which order. Is it iterating from that or from that way? So print taxi name and then do a return. Put a comment here. Where is my console? My print console is gone. The window of the console. Okay, here we go. Console me, console. Let's go. Taxi, taxi, taxi. Then we print taxi, get number of the taxi instead. 1, 2, 3. So it first finds taxi number 1, which is the first one. So iterating in this way, it gives the first one that wants to leave, which is good. So if we treat this in the same order, so if or I mean, we should only be interested in the first taxi. Actually. So always only get the first taxi. And if that taxi is not idle, then we are in trouble. Taxi fleet. Taxi fleet. So if taxi fleet, the status of the taxi is not idle. Stop the model, debug. Why is the first taxi not idle? That's what I want to know. And then don't look for idles, because if we get this far, we can confirm that the first taxi, we have that one, it is idle. And then we wish to return it. And we can put in that if the garage number is 0, no taxis in the garage. If we have no taxis, then we return void, I guess. Like so. Root garage, return void, else get the first one. If that is not idle, debug, return taxi. Now let's see if the model really was working after all. God damn it. Hot potatoes, hot bananas. Hot potatoes at least. Hot bananas is okay. Hot potatoes too. Idle. Poof. Debug. Why is the first taxi not idle? What's gonna happen? He is busy, but he's not left yet. I think he's on the way. Ooh, he's on the way. He hasn't left yet. So when you call get an idle taxi, let's put a breakpoint the first time. See if we can implement a little trick. That first taxi is fine the first time. Cool. Then you say assign a request to the taxi. Okay, I'm gonna do another thing actually. Where did it go? Taxi control. Get idle taxi. Yeah, here's the thing. So we get the taxi. Taxi found is false, while not taxi found, keep doing this. So we have not found a taxi yet. And while we've not found the taxi, you get the first taxi. If that taxi is actually busy, then we're gonna wait for this taxi to leave. Wait until the taxi location is no longer equal to the root garage. And then, when that taxi is no longer on the root garage, get the next taxi that is first in line. And if that is busy, then you also wait. Yeah, let's try this and see if that can fix every problem that we have. And now it crashed. While not taxi found, taxi is garage MU1. What is there? It's the first taxi. If that taxi is busy, wait until that taxi location is not. Why doesn't this work? They're all idle. If it's busy, you wait. Aha! My brain is getting tired, so what you want to do, if it's busy, you want to wait. But else, you have found what you're looking for. Taxi found. Four little taxis leaving. A great joy. Taxi fleet, simulation stats. So the problem was we saw the stats were off. Now let's see if we can get correct stats. So after 1 hour, we end up here. Looking good. And now we get more calls. Those taxis, they do their job and they come back, they're idle. And then we flush the data. And then we flush the data. And then we flush the data every hour, even though nothing is happening. And now I know that the first hour we had some idle ones. The next hour, hour number 2, we had some busy time. I know we had some calls. So we can see from the statistics here that if we compare it to our in data of the taxi jobs, we know that we have 8 taxi jobs. And in the statistics we can see here which taxis were assigned to do which work. We can see that taxi 1 did 1 pickup during the first hour. The next hour it was the same taxi number 1 who was busy doing some pickup. Taxi number 2 did nothing. Taxi number 3. And the reason it was not taxi number 2 is simply because he was not, taxi number 2 was not first in the queue. So taxi number 3, when he get back from the previous jobs, ended up in the queue and he got assigned to do the pickup. And this is quite a clear example on what's hard to mimic when you do Excel calculations, because it would be very hard to predict which taxi would get the job. You can get statistics like on averages, and the taxi fleet will be this and this much percentage used. But when you start to add discrete events and objects and separating their movements in time in a dynamic way like this, and you collect the statistics on what happens, you can actually see which individual taxis do what and how much, compared to the logic that you have that if you're first in queue, then you're gonna get the first job. And that is also maybe what you would like to do if you're running a taxi service, that the faster they are to get back in line to queuing for a job, the faster they're gonna get the next customer. So that would be an incentive. And then after that nothing happens. We can of course in hour 3, hour 4 can put in some jobs maybe, but I think you get the gist. We could also visualize this data in nice graphs. I've not done that now, I've only recorded the raw data. But yeah, I think that concludes the simulation streaming for today. If you have any questions on simulation, if you have simulation that you need to get done, don't hesitate to reach out. You can reach out to me here. You can reach out to me on LinkedIn, where my name is William Falkenström. I think I have a LinkedIn link here in my profile on Twitch. Yes, I do. So if you click on that one, it will take you to my LinkedIn, where you can find my contact if you wish to ask anything or have a request. I'm also the CEO of Recog. We are a small company doing these sorts of simulations, among other things. Besides simulations, we do act in the sphere that I call the manufacturing IT sphere. We analyze data, we do big data crunching, we work with AI, build AI models, we do physics simulation also. So if you want to drop stuff and see how they fall and bounce around, we can do that. What else is there? We come from a production engineering background, so our point of view is always the factories and how we can use our skills and expertise to facilitate factories, help manufacturing organization, how to improve the value streams. And if you're thinking factories, it can be within the factory, it can be a small department of the factory, it can also be a big organization where you have different sites geographically that you need to plan, or that you wish to optimize your production somehow. So we are gladly to help you in any discussions. Feel free to reach out, and yeah, find us on LinkedIn. You could also visit our website. It's called recog.se. You will find that if you head over to LinkedIn. So unless you have any other questions right now, you need to write something really fast. You need to write, wait, because I'm going to end the stream. Okay. I'm reading the silence. I'm checking out. Nice to see a few people here today. Nice with some questions and feedback. It was nice to make it an interactive session. So peace out. Have a good one.